So welcome to Infrastructure for the DBA, an introduction. Before we go any further on the topic, let's get the housekeeping slides out of the way. If you have a cell phone, and I'm guessing you all do, please silence your cell phone. Remember, the learning doesn't end today. If this is your first summit, your learning has just started. If it's not your first summit, your learning has just started because every other session, somebody from Microsoft has announced something that you probably need to learn. Between virtual groups, local groups, SQL Saturdays, online webinars, and all the other offerings that PASS has, you can continue learning from now until we get to Houston next November. So who am I? Well, obviously I'm Peter Shore, because that's what the slide says, and that's who I am. I am a database administrator at a company called 31 Gifts. We make some very nice personalizable bags and things of that nature. I've been in IT 25 years. Yes, that is probably the source of most of this gray hair on my head. I would say I'm an intentionally accidental DBA, which means my resume, if you look at it, screams accidental DBA, except I did it on purpose. I'm not quite right in the head sometimes. I am the president of CBus Pass, which is the local group in Columbus, Ohio. So if you are in central Ohio, whether you're traveling through for work, whether you live there and we haven't met yet, we'd love to have you come out on the second Thursday of every month, including next Thursday. I co-organize SQL Saturday Columbus, which will be in July next year. So all those things I said about come visit us apply for mid-July, hold true for next July as well. Don't forget about session evaluations. As speakers, we love to hear the feedback, how we can make the session better, what you liked about the session so we don't accidentally take it out for somebody else. But please give us some feedback with some details, not just numbers. We want to know what we did well, what we didn't do well, so we can make it better. You can grab those from the passsummit.com website, the guidebook app, or follow the QR link on the signs around the building. And of course, there's that whole note about prizes if you submit your session and evaluations by November 15th. So we're going to cover a lot of stuff today. So I want to warn you, none of this stuff is going to be in depth. And everything that you see on this slide here, you have compatriots who you're going to see when you get back to the office that have made careers out of doing all these things. Clearly, I'm not going to teach you a career's worth of information in a little over an hour. The goal is to make you a little more familiar, a little more comfortable, and a little better able to speak their language, regardless of the specialization, so you can ask better questions, have better conversations as you request resources and as you troubleshoot problems. And perhaps with better conversations, there'll be less frustration and less need for you to buy them a bottle of something as a gift to get out of the... So compute. This is the whole processing piece of things. So these things have something in common. Well, they actually have a lot of things in common. I'm going to go out on a limb and say that everybody in this room has used at least 3 of these today. Now, you may not have realized you used 2 of them, and the reality is you probably used 4 or 5, maybe all 6 of them today. So obviously you recognize the cell phone, the tablet, the laptop, the desktop computer. Next to the desktop computer is a server. Yes, if you did anything that hit a website today, you used a server. And the item next to that is a router. It happens to be a home wireless router, but you have used a router of some kind today because you have made an internet connection. Because I know you've got internet on your phone. That is the least risky statement I have made today in terms of guessing something, that you have internet on your phone. But what I'm actually driving at that they have in common is one of these. This is a motherboard. Over here, these are expansion slots where we could plug in additional cards to the motherboard. If you're a gamer, that big, long white slot to the left, as I look at it, is the PCI Express slot. That's where you would put that really expensive high-end video card. But if you've bought one of those, you probably knew that. The things that I'm interested in right now are this socket, which is a CPU socket. This is a bank of memory. Lo and behold, we have another CPU socket and another bank of memory. The fact that this is a two-socket motherboard tells me in this day and age that it's most likely a server motherboard, because it's very rare to have a workstation motherboard with two sockets in it, unless it's a really high-end workstation. So, as I point here, this area in between, there's some circuitry in the motherboard that connects this CPU to this bank of RAM. There is some circuitry that connects this CPU to this bank of RAM. And there's circuitry in between that connects the two CPUs to each other, which means they can reach that other bank of RAM. However, in compute terms, that is a very expensive connection to make, to cross that CPU boundary. What that creates is a situation where we don't have equal access to the memory. Or another way to say that would be non-uniform memory access, or NUMA. So if we look at this more logical than physical diagram as we talk about NUMA, we can see that there are two CPUs, each having 4 cores, attached to a bank of RAM. We have that remote access in the middle. And this is the reason, when we start thinking about max degree of parallelism in SQL Server, that we want to make sure we keep our max stop at what a physical CPU socket or core count would be, because we want to avoid as much as possible crossing that very expensive interconnect. Does that mean we will never cross it? Of course not. We want to minimize it though. We want to keep that down. That's why we configure max. So again, that's why we configure max stop in such a way that we don't cross those NUMA boundaries. And it doesn't matter how many sockets there are. If we had 4 4-core sockets, 8 4-core sockets, doesn't matter. With this configuration, we would set max stop to 4. Now, we've talked briefly about the max stop and the memory, which is great for processing data, having data in a working location. But I don't know about you, but my users, my business people, they like to be able to get to that data later. So I need to store it somewhere. Of course, there's local storage. We can put local storage in the server. You might put local storage in your lab at home through a SATA drive, where we can, a SATA connection where we can connect a hard disk drive, old school spinning Rust, or an SSD. We can get up to 6 gigabits of transfer rate across this type of connection. May not want to use that for prod. That might be a little slow. Non-volatile memory, much faster. Controller is that PCIe interface type. This was a developed standard around SSD and has kind of become its own thing now. In fact, the new servers I just received and put into production at work, I've got a whole bunch of NVMe RAM, and the TempDB is going to go there soon. This NVRAM, the non-volatile RAM stuff, this is also referred to as PMEM. You may have heard that terminology. New stuff. Original concept was like a flash drive. Now this storage is on RAM chips. It's even faster than the NVMe, because The bus that it's on, which is the term for those wires that run around in the motherboard for the electrons to go back and forth, is much faster. It's right on a RAM chip. A couple of downsides to it, though. Capacities are still small. They're still trying to figure out the whole ability to use the chip as both RAM and storage. And it's new technology. So guess what that means? Big price tags. We have big, big price tags on it right now. Guess what? That's going to come down. As it becomes more commoditized, those prices are going to drop. Local storage has the controller in the server and the physical disk in the server, and we want to configure it, and we're going to configure it then, of course, at the server level. The other thing I mean in this statement, configure at the server level, is we want to configure at the hardware. So that means in a lot of cases, we're going to boot up, press a key, and we're going to get in the hot tub time machine back to 1987. We're going to have that nifty blue and yellow DOS screen that you can only move around with the keyboard maybe. And we're going to configure the array at that level, because we don't necessarily want to configure it at the operating system level, as we can get better performance out of it. How are we going to configure it? The array is going to typically be a RAID, or a redundant array of inexpensive disks. It could also be a redundant array of independent disks. Either term is fine. RAID 0, striping with no parity. You are using both disks. It doesn't really provide any redundancy. It will provide failure if one of them fail. And if one of the disks is, say, 512 gig and one is 1 terabyte, you only get 512 gig. You can't use that other half of gig for the first from that disk. RAID 1, same concept, 2 physical drives, mirrored, so everything that gets written to one is going to get written to the other. Has that same limitation about disk size. However, if one of the disks fails, the other one will still take over. We don't lose everything at that point. That's what the advantage of the mirror is. Downside of the mirror is we're going to pay a write penalty because we have to write everything twice. RAID 5 is striped with parity, requires at least 3 physical disks, and you're effectively going to lose the capacity of one of those disks to the array, to the parity. Outstanding read speeds. Write speeds, we're again going to pay a write penalty. A lot of storage admins still like to use this because it works great for your Excel files. Your database files, that write penalty can be a problem. I suppose if you have a very, very static database that gets read occasionally, that one application that you retired that you have to keep for like 11 billion years because of legal ramifications, and somebody queries it like once a year just to make sure it's still there. If you want to put that on RAID 5, I'm going to say okay. If you're going to query it much more often than that, don't do it. RAID 10, a mirror of stripes, requires a minimum of 4 physical disks, and we must have an even number of disks. Because what we're going to do is we're going to stripe across the disks, and we're going to stripe across all the disks, but it's 2 sets of stripes because we're going to mirror. In that case, we lose the capacity of about 2 of the disks. There's no write penalty in this one, though. Reads are quick, writes are quick. This is the way you want the storage configuration locally. Now, there's a couple of different ways we can have attached storage. Directly attached storage is a chassis, which means it's just a rack. Something, if you've seen the nice tall racks in a server room, maybe if you've never been in your own server room, you might have seen it in a movie. You can mount the disks in this rack. It is directly attached to the server. It is only accessible as a storage device from that server. Of course, you can share that storage out Don't do that with your SQL servers. We don't want other things on those drives. We can use this with a tower server, like one of the big, looks like a big workstation, or a rack mount server. And it's going to allow us to expand the capacity locally attached, but beyond what's physically capable of being put in that server. Network attached storage comes in a lot of flavors and a lot of levels. It all comes with a NAS server or NAS head. Most of the time you don't see it. That is a chip or a small board in the box. It's not a different physical device necessarily. It controls the access to the pieces of disk, the arrays in the individual chassis unit that has the disk in it, managed by the NAS server. We use this with blade or traditional servers. A blade is the very thin pizza box, is a term. 1U is the measurement. Server racks are measured in U's. There is an explicit inch or centimeter to that. I haven't bothered to memorize it because people who do rack and stack of servers just call them U's. The blade's the very thin one. Traditional servers tend to be bigger. We can have multiple servers attached to NAS. Depending on the NAS, there's a wide range of performance. SAN, storage attached networks, divided into local disk units or LUNs. I love how that abbreviation or acronym actually mixes up the word order. We can use this in a very similar way with traditional or blade servers. You might be asking, what's the difference between NAS and SAN then? And yes, I put versus in quotes because it's really not a head-to-head competition battle. They do different things, and they do different things well. As you can see, the NAS connects across TCP/IP networks, most commonly Ethernet. We'll talk about what that means in a little bit. Whereas the SAN runs on a dedicated network type called fiber channel. The service fabric or the fabric of a fiber channel network, there's one drawback that you should be aware of, and I have heard stories of it causing problems for SQL servers, is if there is one adapter or one device that is slower than everything else, the entire fabric will run at the speed of that slowest device. Find that slowest device, replace it, everything comes up. When we look at how the files and the information is accessed, in a NAS, we're talking at the file level as opposed to the block level. We all know what files are. Blocks are the little allocations of disk that we get written to, or they get physically written to. SANs do a little bit more work in that place, but they can also be a little more specific and tend to be a little faster. They use a whole bunch of protocols to communicate, whether we're talking NFS, SMB, or HTTP. Yes, you can make web connections to a NAS. If you have a home media server that you hit through a website, that's effectively a NAS. We have a whole bunch of other connection types, that fiber channel, iSCSI, which can go across a network, fiber channel over Ethernet. So we can use Ethernet to support fiber channel, and the NVMe connection type over fiber channel. Gives us some options depending on how the storage engineer wants to talk about things. And again, do you need to know what these protocols all mean in deep detail? No. But it's nice to know what the storage admin's talking about when he says something or she says something. Performance is a little lower in the NAS, generally. High-end NAS can perform pretty well. High-end NAS is expensive. At that point, you may want to get into a SAN because that has a tendency to perform better. SANs tend to be more expensive. Scaling depends on the level of the device. But both can scale. Look at different manufacturers and different models for details on scaling of your particular devices. We could talk about that for a while, so we're not going to deal with it much because we've got stuff to cover. It's a little harder to manage SANs because they're a little more complicated, have a little bit more dedicated software to manage them, which also means you can get a little more information out of them when you're troubleshooting. NAS tends to be a little easier to manage, a little simpler to manage, I should say, which doesn't necessarily mean it's easy. And we mentioned price already. Depends on the level of the device, but we're going to hit a lot of SANs when we go out to our favorite website and sort lowest price to highest price. We're going to see more NAS before we get to any SAN. Now, quick show of hands. Who here is scared of virtualizing any of their SQL servers? Or if scared isn't the right word, concerned, question it. And it's okay if you are. Who here's a little nervous about putting servers in the cloud? There are some reasons. I will tell you, if your reason is security, just think about it this way. Last I had heard, which is about 4 years ago, Microsoft spends about $2 billion a data center, and they have 54 data centers. You do the math on that, they have over 100 billion reasons why Microsoft can't be the problem if there's a breach. Just in case there's any concern, almost all SQL Server workloads can be virtualized. Go figure, there's caveats. You have to have the right hardware. And what do I mean by the right hardware? You have to have physical hosts that are capable of handling the workload, just like if you don't virtualize the SQL Server. No surprise here, we've got to configure it properly. Now, I will say, even at this conference that Microsoft has so wonderfully sponsored, from what I have talked to people about, VMware outpaces Hyper-V in the real world in production by about 75-1. So for the most part, I'm going to reference VMware. Properly configured, VMware has a fantastic white paper that they keep updated. Send it to your virtualization admin, tell them to build all their VMs to the specs of that document. When they argue, tell them they're wrong, politely, nicely, kindly. Tell them that some of the best people in the world outside of VMware worked on that document with the VMware engineers, and ask them very nicely to follow it. It will tell you how to configure everything from the host all the way up through the virtualization layer and into the VM, and how to spec out the way the VM is built. But before you can request those machines, you need to understand your workload. You need to be monitoring, which you're all doing anyway, right? And if you're not, hopefully you talk to some of the monitoring vendors that sponsored here today, or this week. You need to monitor your servers. You need to know what your workload is, whether you're going to take it to virtualization on-prem or to the cloud, so you can size them properly. So what's virtualization actually do? I'm sure you've read the words already, but let's talk about them. Creates a layer, an abstraction layer. So the operating system, whether it's Windows or Linux, Apple really doesn't like it if you try and virtualize Mac OS. You violate all sorts of terms of their licensing agreement. Creates a virtualization layer between the server, the Windows operating system, and the physical hardware. Not unlike the abstraction that Windows creates between SQL OS and the hardware. So VMware says, or Hyper-V says, Windows Server, you have this small amount of hardware compared to what's physically in the box. What's that allow you to do? It allows you to have multiple servers to run multiple workloads on one physical piece of hardware. So you spend a little more for the hardware, you get some more bang for the buck out of it. Yes, it means we have to potentially worry about noisy neighbors. Yes, we need to monitor that, work with our VM folks to make sure it's monitored. When we think about virtualization, we're generally thinking about multiple virtual hosts. Both VMware and Hyper-V have the capability to move a virtual machine from one host to another. It does that by freezing the I/O, so we don't want it to happen a lot, but it is certainly a viable thing to have happen. We just don't want to do it all the time. Which means we can use the virtualization layer as part, but not all, of a high availability solution. So if that one host fails, VMware or Hyper-V will figure out what was on that host and spin it up on another host where there are available resources. The downside, from a SQL Server perspective, is we have to go through the process of the host goes down, the hypervisor identifies what was on there, finds a spot to spin it up, spins it up, and now we can start crash recovery. If we're using one of the HA methods, such as an availability group, see, Windows Server says, hey, I can't find the other half of this cluster, boom, I'm going to fail over. We don't have to go through crash recovery. We have a faster turnaround time for that recovery. But the virtualization layer is a viable part of that HA solution. What I mean by backup approach can be an issue. There are some tools out there, some backup solutions that allow you to take what are called snapshot backups of the entire VM. And it's just like taking a picture. It freezes the VM, freezes all the I/O, and takes a picture, makes a copy of that static machine state. What that does not do is take into account in-flight SQL Server transactions. So we either need to make sure we have configured those products properly, because the ranked one of those on the market is more than capable of doing our full and transaction log backups. We just have to configure it properly. Or we need to come to an agreement with our virtualization and backup admins, say, you snapshot the OS and the installed SQL, exclude the drives where my data files are, and I will run native SQL backups. Either way works. There are these new things. Anybody hear about containers this week? Containers, Kubernetes, that word like rattling around in your head? When we look at virtual machines over here, we can see we have the hardware, the host operating system, maybe, depending on the type of hypervisor, the hypervisor, and then the entire contents of this machine, OS, applications, everything it needs. Same here. In container world, we have the physical, then up into the host operating system, the container daemon. Yes, it's a daemon. Yes, that means this is born in Linux land. Then we have just enough of the OS to account for any differences. So if it needs a particular subset of the OS, that's all that's in the container. It uses the rest of the OS from the host and then the app. So it makes it that much more efficient to use from a storage perspective particularly, because it's still virtualization as we virtualize the environment. Also means we can deploy it a lot faster. You've probably heard about that too, that whole Kubernetes thing. The cloud itself. Infrastructure as a service. Somebody else's data center. It's virtualization. You're just doing it on somebody else's hardware. Somebody else takes care of that hardware. Can replace almost every piece of your server infrastructure. It still behaves like your servers. It's still just like how you run SQL Server virtualized today. You have access to all the components. And there are valid reasons that you may need to do that. If you need specific components to work in specific ways, this is the way you have to do it. I personally think that you're not fully taking advantage of the cloud if you're an IaaS. That is my personal opinion. Others do differ with me on that. When we start to look at platform as a service, this is Azure SQL Managed Instance, Azure SQL DB, all those platform as a service pieces. We can only really virtualize our back-end systems. We lose some of what we can virtualize. The cloud vendor takes care of a lot more of the management through such as patching than we do in the infrastructure as a service piece. Does not at all wholly replace that on-site infrastructure. I think this is the future of cloud. This is the spot where I think the most attention is going to come in cloud, because all that machine learning stuff, quantum, Azure Synapse. You heard about that this week? That's where this lives, platform as a service. I can't mention cloud without mentioning software as a service. But I think we're all going to agree on this point. When Office 365 came online, Microsoft won software as a service because they already owned it on the desktop. This is your productivity software. This is Word in the cloud, Excel in the cloud, Exchange in the cloud. Power BI actually lives under this piece. But Microsoft won this one already. The jury's still out on the other two. Now, pizza as a service. No, this isn't technical. I would love to give credit to the person who originally came up with this diagram, but I think it has been around the internet enough times where the person who originally came up with it doesn't realize that they are the one who originally came up with it. It's nowhere near a perfect analog for cloud. However, it gives you some concepts. The general idea, depending on the level of service you're looking at, the blue stuff you're in charge of, the green stuff the cloud provider is in charge of. So the one where it's all blue is traditional on-prem. The one where it's all green is software as a service. You can see what you, and by you I mean your corporate team, which may be literally just you, depending on the size of your shop, has to manage. So you can see how we can make some decisions that, hey, all I've got to manage in platform as a service is these couple things. Great. I don't have to do that redundant patching task. There's a fantastic make your eyes bleed kind of level of detail, get your nerd on kind of thing, blog post that you can look up on how Microsoft actually goes through the process of patching SQL Server in the cloud live so that you don't see a service interruption. Make sure you're ready to get a little nerd deepness in that one before you read it. Don't read that as casual, reading before bedtime. This is the way Microsoft displays a graphic of the cloud. And it's really just a different way to show the same kind of thing, how IaaS, PaaS, and SaaS relate to each other. I like to put this in there because it gives people a concept from a business perspective, how we're going to look at it. And you can see the data center on the one side all the way over to the application. More business appropriate, a little less humorous than pizza as a service. Let me say this about cloud. If you are under the impression that cloud is going to save you money, you really need to look at that again. It is not a money-saving method. Maybe. Okay, let me not make that 100% definite. Maybe. If you happen to work for the kind of company that knows exactly how much it costs to run a server, and by exactly how much, you can divide the power bill and allocate X amount of the power bill to that server and including the cooling and the space and everything, and you can start eliminating those on-prem servers and reducing those costs, then maybe the cloud will save you money. I'm guessing 98% of companies don't track to that level of detail. The cloud does provide a lot of flexibility, a lot of ease of management, and yes, there are companies out there who are running entirely in the cloud, as Microsoft has talked about to a great deal, both at Ignite and here at Summit this week. Hybrid is a very real thing. And it's okay. There are some edge case workloads that just will never fit for cloud, and that's okay. So transport, because once we have everything in the cloud or in virtualized, or heck, we just want to get to it from our desktop because we don't allow all the users to go into the server room, right? If we're on-prem, we're not letting everybody in the server room. We've got to connect somewhere. For the most part, we're connecting across a LAN, a local area network. This includes wireless. Wireless is part of a LAN. There's a really good chance you have one of these at home. If you're a student, you've probably got one. In your office, you almost certainly have one. If you've got a couple of office buildings right next to each other, it still falls into a LAN. Yes, there used to be a term called CAN, a campus area network, which would have covered those couple of office buildings next to each other. As far as I can tell, that term has kind of fizzled. Wide area network, or WAN. There used to be a metropolitan area network, a MAN, that was, when you had a connection across a metropolitan area. That's just become a WAN. Connects multiple data centers together. Congratulations, I don't care how small your business is, you have all used a WAN and you have used it today. How do I know that? Because you all have internet on your phones. The internet is a WAN. It is a wide area network. Very wide, covers the whole globe. Pretty much the whole globe. I'm not sure how good the internet connection is in Antarctica. Virtual private network. Show of hands, how many people VPN into the office? You're using one of these. Virtual private network. Creates an encrypted connection, a tunnel, through a wide area network, most often the internet. So we have improvements in security and privacy across our connection, which is what our employers want us to have. We don't want our confidential employment data just scattered hinter and yon. We can also, let's be honest, there's also another side of the VPN connections where we can be in another part of the world and get the Netflix stuff that we're used to here that's blocked there, all right? That is a thing. I'm not saying you should do that thing, but it is a thing. Virtual Local Area Network, or VLAN. This has nothing to do with those hypervisors I was talking about. Your network admins can divide up the existing bandwidth of your network. It does not expand the bandwidth. They can divide it up so we can manage the traffic and security. We can give some things, some priority, some types of communication priority. If you've got one of those NAS devices, or maybe you've got a fiber channel over Ethernet SAN, they may divide it up and give that storage traffic a higher quality of service ranking so it gets a little more of the bandwidth. Where I'm from, in Columbus, Ohio, which is the capital of Ohio, I've talked to a network engineer at the State House, where the representatives from across the state meet. They use VLANs there. What are they separating? Here in the US, the Democrats have one VLAN, the Republicans have a different one. So if you're from Ohio, you don't have to be concerned that whichever party you like, their network traffic is being seen by the other party. Your mileage may vary in other states or other countries. Bandwidth versus latency. Bandwidth is the maximum throughput. Everybody has seen a highway, right? You got multiple lanes, that's your bandwidth. That's how much throughput we can have. Latency is how long it takes you to get from exit 1 to exit 2. 3 o'clock Sunday morning, when you're trying to get to the airport to go on vacation, it probably doesn't take very long to get from exit 1 to exit 2. 3 o'clock Friday afternoon, when everybody's trying to get out of town for a long holiday weekend, probably takes you a little longer to get to the airport. Now, I should say that latency is a dual term. Latency doesn't just apply here to networking. Latency applies to the storage world we talked about earlier as well, and it means the same thing in that case. I know, unusual situation. A term in computing and technology actually means the same thing in 2 different places. Your storage admins will talk about IOPS instead of bandwidth, input-output operations per second. We want lots of those, but just because it's capable of processing a lot of those doesn't mean that we aren't having a backup in latency. Both network admins and storage admins will push we have high bandwidth, we have high IOPS. You gotta get them to look at the latency. Go to them with data, your data professionals. Go to them with data, say, this is what I'm seeing. I think we've got some latency going on. Be nice about it, don't tell them that it's their problem. Be kind, say, I think, I wanna investigate, I wanna eliminate. And then when it becomes their problem, let them fix it. We gotta have some devices, because this network stuff doesn't just happen by magic. It is not a pure flippin' magic technology. We have these things called switches. Originally, switches worked in such a way where they just brought traffic together across Ethernet. And I told you I would explain what Ethernet is. Ethernet is a standard by which wired network traffic happens. There's a lot we could go into with it, but today we look at Ethernet in terms of RJ45 cables. Those things that look like telephone cables that need to go on a diet, that are under your desk with the really wide connections that don't fit so well where the phone jack goes. For those of you who remember what phone jacks look like, that's an Ethernet cable. It's a wired connection. We consolidate those from the one that's under your desk at work, gets consolidated through wires in the wall back to a switch. The switch can just bring that together, flatten out what's called a broadcast domain, so make everything has more direct connection, and bring it back to the network. There's another type of switch that works at another layer of the network called a layer 3 switch. That'll make a little more sense in a moment, where it can do some routing. We'll talk about routing on the next slide, where it can redirect some packets. Either way, we need switches, because switches build networks. I'm not going to argue with Cisco's definition on that. They kind of invented this whole network devices vendor kind of thing. And you have no doubt looked at the kinds of things that we can connect with them. It's all the things you would expect. A firewall. In real simple terms, we use firewalls to keep the bad guys out. Are they perfect? No. There are different types of firewalls. We can do packet filtering. Each little piece of traffic that goes across your network is broken into a packet. We can filter that based on contents of the packet. We can do stateful inspection, where we can tell some things about the state and the connectivity of the packet and drop those packets. Then there are these things called next-gen firewalls, IPS, IDS, intrusion protection system, intrusion detection system, or prevention system, intrusion detection system. Those do what those names say they do. They detect or prevent intrusions from happening. These things happen at the edge of the network. Network security is a multi-layered approach. You don't want to have just one thing. Routers connect networks. Again, we're going to quote Cisco on that. Since they connect networks, clearly we're talking about the ones from Cisco, not from Black & Decker. We're not doing any woodworking in this session. You can have them in LANs or WANs. Sometimes we want to segment our LANs in a little more physical manner than a VLAN. So we will put them a router between segments of the LAN, or it will be at the edge connecting to a WAN. Regardless of the routing protocol in use, and there are many of them, at a basic level, a router knows its neighbors. It doesn't know anything beyond its neighbors. And it takes a packet and says, oh, you want to go to Google? Go that way. You want to go to Google? And when it says go that way, it believes that that next hop router has the fastest connection. Oh, it now knows this one's busy. Next packet goes this way. Yes, your message may go all over the place, and it'll get reassembled at the other end. What we have here is a relatively simple network. We have the internet, one of those routers. Here's a firewall. Notice the router's on the outside of the firewall. Then we have a switch, a server, a wireless access point. Okay, so the thing that I find funny about this is, why is there a PDA that's wired, a personal digital assistant? I'm old enough to have actually owned one of those. There was no such thing that I recall as a network connection for those. And why it's in with an IP phone, I have no idea. Pardon me. We can see the laptops, of course, connected to the wireless access point. Now, on the next slide, please ignore product names. I don't know what they all are either. This is a more complicated network. So this company has some internal wide area network, so they've probably got multiple offices. We've still got connections. I will tell you that anything that says ASA from Cisco is a firewall, an intrusion device. We have this thing here called a DMZ, routers, the internet. What's a DMZ? DMZ is a stolen military term for demilitarized zone. If you know anything about the area between North and South Korea, that is a demilitarized zone from a military perspective. It's a protected area, it's an air gap, it's a buffer. It's not a true air gap. In military terms it is, in network terms it's not. What you have in the DMZ are probably your web servers, anything that needs to be connected to from the internet. Do not ever put your SQL Server there. Do not do it. Well, if you want to have a little fun and you have a SQL Server with no data on it, go ahead and put it out there and see what happens. SQL Server is secure, but boy, oh boy, is it going to get attacked a lot. Data is valuable. What happens is that inner set of firewalls allow just the connections necessary through. So the only thing that's authorized to make a connection to that database server is the web server, or whatever else is out there. I use web servers as the example because that's the common one, right? Now, there's this thing called TCP/IP. A little history lesson. It was originally developed in the late 1960s, and it went into production as we know it today in 1978. Those of you who are old enough and from the US may remember the running joke in the 90s that Al Gore invented the internet. I present you proof that Al Gore did not invent the internet. Truth is, if you look at his voting history, he did actually help fund it, but we're not getting any further political than that. IPv4 was born out of the Department of Defense and into this thing called ARPANET, where it went in production in ARPANET in 1983. It's a 32-bit address pattern, and that's what, roughly 4 billion addresses, 2 to the 32nd. Some we lose for some particular rules. We gain some back because of this thing called network address translation that allows us to have some networks in various places. But we're running out of addresses. Anybody guess why we're running out of addresses? Because y'all got internet on your phones. That's okay. You've got internet on your phones. China has internet on their phones. There's a lot of people in China. There's a lot of people in India that have internet on their phones. It's just not mathematically feasible. It ran into a scaling issue. Hence this thing called IPv6 got invented. If you're a math numbery type person and you want to think about what 3.4 times 10 to the 38th actually works out to, I bless thee, go forth and do so. I know it's a really flippin' big number because it's a 128-bit address. It's not directly interoperable with IPv4, however, which has made for some challenges from an adoption perspective. By default, Windows devices have IPv6 enabled, along with IPv4 in most cases. So we're using IPv6 more and more. But we still, when we talk about IP addresses, talk in terms of IPv4, because we get that 192.168.1.1. Yes, I just said the default gateway address of probably about 80% of your wireless networks in the room. Why? Because that's the one everybody uses. And by everybody, I mean the vendors, not you personally. You might have chosen something else. IPv6 uses an address that has 8 groups of 4 hexadecimal digits. It looks like a big GUID, because effectively it's a big GUID. So we don't ever talk about those. So within this, we have Internet Protocol, which handles the communications logistics. The routing piece of TCP/IP lives here. Make sure the connections happen. TCP, the Transmission Control Protocol, is very reliable because it actually makes and maintains a direct connection, which not surprisingly causes some overhead. Tremendous and horrendous overhead? No. But, overhead nonetheless. Use a datagram protocol. It's connectionless, so it just sends it out, and it never knows if the packet actually arrived. There's a lot less overhead to that. We don't make the decisions as to what's used from this protocol stack level. The network engineers don't necessarily make. The real hardcore computer sciencey, networky type folks who build the protocol stacks and the software, they're the ones who figure this out. TCP/IP communicates across ports. We've all heard port 1433, right? Everybody who's a SQL Server DBA is nodding their head. Yay! The few folks who aren't, I'm assuming, are developers and don't have to worry about that. A port allows a particular service to connect across the protocol. An example of that is think of TCP/IP connections as your cable signal. Each channel is akin to a port. You get something different on channel 3 than you do on channel 4. You get something different on port 22 than you do on port 25, or on port 1433. Those firewalls we talked about can block specific ports as well. So you've probably had a situation where you've had to talk to a network engineer. Hey, I need you to open port 1433 so I can manage this SQL server so it can connect to a specific application server, or an application server can connect to it. Network models. Yes, networks have models too. It's not just for data. The OSI model is the standard. Why is TCP/IP different? TCP/IP is older than the OSI model. When I was making reference to layer 2 and layer 3 when we were talking about switches, that's layer 2, the data link layer of the OSI model, and layer 3, the network layer of the OSI model. The data link layer is where direct network connections happen on the same network space. The network layer is where we can communicate between different networks. So, and remember this at the top, the application layer. We'll get back to that in a minute. So what happens is each layer encapsulates something onto the packet, or onto the data portion of the packet. It gets added on, we go down the stack, and eventually it gets down to that physical layer, goes across as ones and zeros, goes back up the other side, and each of those header pieces gets stripped off. Acknowledgements are sent where they're necessary, and then we can read the data. A network packet will not hold your entire result set of your query, so your query results get broken down into little pieces and get reassembled at the other end and presented back to you. Those network applications I talked about, there are more than just these two. These are very relevant to us, though. Dynamic Host Configuration Protocol, DHCP, hands out network addresses. Hands it out. We typically use the dynamic part of this for workstations, phones, laptops, and the like. So that's where, and we can do servers in that as well. DNS is the Internet Phone Book, because other than a couple of very specific DNS addresses, DNS servers where we get this phone book from, you can't remember any more network addresses than I can. We don't go to whatever Google's IP address is. We go to google.com, we go to microsoft.com, we go to amazon.com, we go to our company website.com. Canonical names, the CNAME, this you may want to make a note of. You can assign a canonical name to your SQL Server, to the instance. So if it's an HR database, they can connect to HR. Doesn't matter what the server name is. What's that mean you can do? You can upgrade that server to a new piece of hardware with a new server name and just repoint the DNS record, wait for DNS to flush it a little bit, and they connect, and it doesn't matter to them. You have to tack on the instance name, of course, if it's a named instance, but they don't have to change their connection string when you change your server. Wired networks are more secure because it's harder to get to them. And it's better for data centers because they suffer less from interference. But they're less flexible because we got to put it in the walls, therefore they're more costly to install. Wireless networks, up here in the front of the room, looks to be, if it's not there, it's on either side, a wireless access point. They're much cheaper to install because you've only got to pull one wire to it. However, they are less secure. It is possible to do some things called man-in-the-middle attacks, where somebody could be running a false connection point somewhere else close to you. Your phone would connect to the stronger connection point. As long as they pass the signal up, you're none the wiser, and they're taking your information. This is why we use VPNs when we work at Starbucks or Panera Bread or whatever your Wi-Fi coffee shop hotspot of choice is. Additionally, wireless networks are slower tier by tier than wired networks. Wireless fastest network is about 1 gigabit. Wired fastest network is about 100 gigabit. Windows itself. All right, mea culpa here, admission. I don't do enough with Linux at this point to have put any Linux in this conversation. So nobody asks me about that because I can spell Linux and that's about where my knowledge ends. My friends who know Linux have already started to give me some static about that, and I'm working on it. If you build the Windows servers, there are 2 ways to build it. The desktop version with our traditional graphical user interface, the GUI, It's the Windows we all know and love and curse at and hate. Depends on the moment, right? We need this one for certain things like reporting services, where we need the GUI interface. We also have Windows Server Core. It doesn't have a GUI. It's all command line driven, unless you're using Windows Admin Center, which you can download from Microsoft. You may have heard the code name Project Honolulu. Otherwise, to manage Windows Server Core, PowerShell all the things. A configuration note for Windows. Microsoft keeps changing this, server version by server version, at least the default state. TCP chimney offload, which transfers some workload from the CPU to the NIC, which we would think would be great. There's more CPU for our SQL Server. You want to disable this because it's designed for short-term connections it's designed for connections that are the exact opposite type of the way SQL Server wants to connect, basically. And depending on the version of Windows Server you're looking at, it's either set to automatic, enabled, or disabled. You got to look and physically disable it. Windows Server 2019, it's supposed to have been removed. I haven't looked at enough Windows Server 2019 yet to confirm that. Windows has these things called policies. Local policies, like lock pages in memory, and perform volume maintenance, aka instant file initialization. Configure these on the local machine. And we want to make sure that those policies are set if we need them. Power would also be configurable on the local machine. Guess what? Some of our performance problems with SQL Server, we need to look at from the Windows side of things. Perfmon is the way to do that. We can look at CPU, we can look at memory, we can look at disk. There are a lot of counters that are installed by specific applications, like SQL Server. There are a large number of counters. Yes, you can access most of those counters through the sys.dm_os perf counters DMV, but there are some additional ones outside of that we can look at. And if we're in a hypervisor environment, there are counters specific to the hypervisor we can look at in Windows that don't get captured in that DMV. I've included a link to Heroflux.com's website that has some best practices on setting up the perfmon counters, and it includes the perfmon counters for both VMware and Hyper-V. Obviously, if you're going to set up perfmon counters on a physical server that's not virtualized, ignore those that are related to the virtualization layer because they're not going to be there anyway. Microsoft has a tool called the Windows Performance Toolkit. It has two components. We can record what's going on, and then we can analyze it. The subject that I have most specifically used this for is it gives us more detail about disk access. There's this thing. It's called Active Directory. You've probably heard of it. It is, in itself, a database. It's a hierarchical database. It's made up of objects that have properties that are organized by organizational units. That when you look in Active Directory users and computers, the icon looks suspiciously like a folder. I highly advise that you work with your Windows team to move your SQL servers into their own OU, or organizational unit, because then we can apply group policies to them that are scoped only to those servers, such as who gets perform volume maintenance, who gets local or lock pages in memory, define the power plan. since the default power plan in Windows is balanced, which means you only get about 25% of all that lovely CPU you're paying for. In general, group policy allows us to manage settings on the Windows computer at the computer level or the user level to effectively baseline the experience and the configuration of the servers. Two types of accounts you want to think about for your service accounts. Managed service accounts have been around since Active Directory functional level 2008. They are technically a variant of a computer account in Windows. What's really cool about them is every 30 days they'll change passwords. Guess what? Your domain join computer every day, every 30 days its computer account changes passwords. You don't know it. Not only do you know, and by it I mean you don't know the password and you don't know it changes. It just changes. The Windows admins don't know it either. The same process happens for managed service accounts, which means if you're in an environment that requires from a security perspective that you change those service account passwords periodically, no downtime, it just happens. The problem with managed service accounts by themselves is that they're specific to a computer, which causes us a problem for things like failover clusters, availability groups. The group managed service account can be assigned to more than one computer, as long as you've got SQL Server 2016 or higher, because that's where it is officially supported. There's some configuration that has to be done with PowerShell to get them set up, but I'd recommend that you look at them, particularly if you work in any kind of environment that requires a service account passwords to be changed. Speaking of all things secure, just touch a couple things here. SSL, Secure Socket Layer, creates an encrypted connection using, it's a certificate-based encryption. You've probably seen the HTTPS in your browser, particularly if you use Chrome, it forces it. Firefox, I believe, does as well. I suspect, particularly now that Edge is Chromium-based, it will as well. If you're using these, buy the certificates, self-sign. I don't necessarily think you should use a self-signed certificate, but also make sure you stick to reputable vendors. So do a little research on where you're buying it from. You want those certificates to be valid. You want them to be secure, because when they start coming from the El Cheapo Deluxe vendor, then we start to have a problem. Antivirus. Yes, we can have an argument about whether or not we should have antivirus on our SQL servers. Yes, there are good points on both sides of that argument. What I would ask is Microsoft has an excellent list for all of their products, actually, not just SQL Server, of where the exceptions should be in your antivirus policies. Just make sure those are set up correctly. Work with your antivirus admin to make sure that those exceptions are in place if you're going to use antivirus on your SQL Server. Anybody have any questions? We've touched on a lot of things today. No questions? I didn't lose anybody? Maybe somebody's too lost to even figure out what question to ask me. I'll be happy to answer questions in person after the session. Again, don't forget your session evaluations. Give us the feedback so that I can be a better speaker. Do the session evaluations for every session you went to, so your other speakers that you saw this week and learned so much from can become better speakers, so that you can learn more from them next year or at a SQL Saturday in 2 weeks or whatever. Thank you for attending. Again, my contact information, you can find me on Twitter at pshore73. Please go ahead and follow me. If you are new to this community, please let me know that, and I will retweet you and introduce you to the whole community. The SQL family is a fantastic group. And you can reach me at pshore73@outlook.com if you have a question that comes up later. And with that, I would like to thank you again for your attendance in my session today and for coming to Past Summit.